And now we're going to talk about reflecting. Reflecting would be basically reflecting across one of the axes. So you got your y-axis and your x-axis. So if we had, let's say, I don't know, y equals absolute value of negative x, doesn't matter. This would simply look like something like this once you graphed it. And if they told you to reflect this, all you would simply do is flip it right at the origin, right here. And it's just going to do, just as you probably already thought. It's just going to flip right across the x-axis. So if we had something, if we had another graph that was like this, or it was doing this, and they wanted you to flip it along the y-axis, well, you're just going to have this. It's just going to be the mirror image. So this was the old, and this was the new after you flipped it. Again, this was the old side. This was after you flipped it, so this is your new side. If you had something like, trying to think one off the top of my head here, like a parabola, and you flipped it, again, it's going to be basically the same thing. What if you had a cube, where you were doing something like this? Whoops. And they wanted you to flip it along the y-axis. Well, then you're going to have something like that. So hopefully this is pretty straightforward, and you're just flipping your picture or your graph along whatever axis they tell you, X or Y. So next we can talk about symmetry with respect to a given axis, so one of the axes. So let's just look at this one here, where we have x equals the absolute value of y. Again, just go to your little chart, like I'm doing here, 0, 1, negative 1, and we can plug those values in for x. So if x equals 0, what would y be? Well, the only thing that's going to equal 0 in this case is going to be 0. If x is 1, y could be what? Well, y could be 1 or negative 1. 1 or negative 1. So what if x was negative 1? What number or what value can we plug in for y, absolute value of y, and get a negative answer? Well, there's not going to be one, because no matter what you do or what you plug in there, the absolute value of it's going to take away the negative, so there aren't any here. So that should be kind of a tip-off to you for when you're graphing this, that you're not going to have a negative x value. So what that's going to be, you're just going to graph your points. You got 0, 0, and then right here you have 2 points. You have 1, 1, and you have 1, negative 1. So it's going to look like this. And with the absolute value, it is a straight line, so you will be connecting your dots this time, as opposed to like with the parabola. And I guess I should have said the question here is going to be basically this. I'm asking you, what axis is a symmetry with respect to? Well, you can see that you can flip this left or up or down, like this, and the graph will end up falling upon itself. So if you were to take this up here, it would have this point and this point. Same thing here. So as you can see, they're going to be the same points. So this is going to have x-axis symmetry. Okay. Now what if we had y equals x minus 3? Well, again, You don't know what it looks like, so plug in your little chart here. 0, 1, -1. So if we plug in 0 for x, you're going to have -3 for y. We plug in 1, you're going to have -2. We plug in -1, again, you're going to have -2. So, with that being said, we'll just graph these few points to get an idea of what's going on. So we're at 0, -3. We're at 1, -2. We're at -1, and -2 again. And because this is going to have the absolute value in it, it's going to look similar to this one over here, but this -3, this is actually just going to bump it down 3 spots, just like it did here. So we're going to have a straight line off this point going either direction. And now the question is what axis does this have symmetry with respect to? Well, it's going to be your y-axis, and that's because these points are directly across from each other. These points will be directly across from each other. Or you can also think of it as this point and this point, they have the same x value, basically. Same thing here. It's the same spot, same location. So this is the y-axis. Or I'm sorry, not the x value, but the y value. As you can see, these are both at -2. These are both at 0, where y equals 0. And the same thing on this one over here. These are both at 1 on the x value, or x-axis. These are both at the same x axis. So okay, one more example, kind of a trick question. X squared plus y squared equals, say, 25. Well, from the previous sections, we know what this is going to look like. We know because it's x squared plus y squared that our center point is going to be at the origin. And we also know our radius is going to be 25, the square root of 25, which is 5. So our graph is going to look like this. We're at our origin. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we've got these far-reaching points. Now we just connect those points with a circle. And there's our circle. Now, if we were to ask what axis is this symmetric to? Well, you could argue that it's symmetric to the y-axis and the x-axis, and you'd be right. So this is the y and the x-axis. They were symmetric to both of them. So don't let the circles confuse you. Kind of tricky.